Welcome to all. Question 54, some important, this is a very powerful question for two reasons. Reason one, see, finding dimensions. For when you divide into different parts, what is the dimension for each part? If it is a rectangle, base and height. If it is a triangle, again base and height. If it is semicircle or circle or quadrant of a circle, what is the diameter, and also radius you should know correctly how to mark, because by half the diameter is radius. Sometimes radius required, okay, but we calculate everything in terms of diameter. Second reason, after some long time now, this question, centroid location, I decided to explain once again as a refreshing for you. See, just refresh. So now, but more important, you can tell three reasons. The last reason is, if you want to really understand each and every concept, then such questions you should solve and get the solid grip. That is very important. Okay, start. Find moment of inertia about centroidal axis. So I won't waste time on this one now. IXX, IYY passing through centroid capital G. That is red color I am writing. That all as usual. I will skip that one. To first you have to locate centroid G using X bar and Y bar. You can take either Abelco or Eterco. I will take both this time today to make class will be lengthy one, no problem. Okay, start. This is a given sketch. See, now, see this point from here looks like to little right side. They should be careful. See, as per the sketch, see this is little right side. Anyway, that much the person who sets the question should know it. Now, first of all, you check, is there any missing dimensions are there? If missing dimensions are there, we can't solve. So how to check it? You go for geometric construction. See, what I will do is, see, I will start from here. I will start from this point, right point. I will start from right point. Okay. Then, from here, I will go right side up to here. How to go up to here? See, this is 120 given. Okay. So you go by 120. Further, this radius given 110. So further by 110. So, but 120 you go, 110 you go. But when you go by 120 and 110, you reach this level somewhere here. So 120 plus 110 minus 30, you get this point. Okay. Now you reached here. Then from there, you draw a semicircle of radius 75 or diameter 150. Okay. You reach this point. Then go right by 135 and finally, see, right over, I will put double right. You reached here. Now, here you can't go because why? See, it's inclined. Leave it now. First, come to this point. How to come to that point? See here. From here, you go right side by 120. Okay, you get a point. See, 120. Then 120, go vertically up by total given 300. This radius is 110. So go vertically up by 190. Okay, this point you will reach. From there, go further here, mark the center and draw a quadrant here. You reach this point. From this point, go right side by 200. You reach this point. So I will put triple right. Okay. Join double right to triple right. Yes, you can join it. So there are no missing dimension. Given sketch is correct. Okay, now, how to divide into parts? That is not a difficulty one. See, you write this sketch first. Write one more sketch to understand. But here I can't write because space is not there. So this is the given question. I will remove the given question now. I will remove the given question and write the question once again. See. Okay. Given question removed. You can see empty board here. See. You cannot see anything. Empty board. Now I will write the given sketch once again. Okay. Now see here. Then See here, okay, this way we will divide. Now I will name the points here. See, I will call this point as A, this point as B to understand. This is C, this is D. So I will take, this is part number 1. See, I will remove that. This all I will remove now. Second time, this is not given. Okay, I will remove it. So here also complete. Sorry, I forgot. Okay, now this 30 is still required. I will take this as part 1. So your part 1 is a rectangle. Rectangle AB DC. AB DC, where AB is the base and DC is the height. Okay, then I will first write that rectangle here. See, this is part 1, this rectangle. Don't see other things. This is your point A. See, this is your point A. Later I am removing it now. This is your point B. This is your point C. This is your point D. Now get all the dimension. What is A to C? A to C is, see, 300 given in the question. I have written here, see. I have written here. Some dimension I have written that side, some this side, depending on space. This is 300 vertical. Horizontally, how much is this one? There you cannot tell because this offset is still not known. See, this 200 is where, see, they told see, this is D, they told 200 is from here to here. See, this is 200. Therefore, this offset is not known. Leave it. Try here. A to B, see, this is A to here. See, this is 110. See, this edge, right edge of the quadrant and where semicircle starts, they told left by 30. So, from here to here is 30. So, this distance you require, it is 110 minus 30 is 80. I write here how 110 minus 30 is 80. So this is 80 and this is diameter of the quadrant, sorry, semicircle. Radius 75 means 150. Therefore, A to B is 80 plus 150 plus 35. Calculate. Dimension calculated 80 plus 150 plus 35 is 265. That's how I got 265 here. Okay. Rectangle is clear. See, now this is not there. So actually one rectangle. 2 I will take this one. This I will take 2. It's a quadrant, right here. It's a quadrant of a circle whereas this 2 will become cut out. Because, see, actually area is here. But we are taking this much. So, real existing area in the rectangle portion is this area minus this area. So, 2 I will remove. 110. See, the radius is 110. I will mark here. Radius 110. Here also I will mark 110. 110, 110. Now, then, since the radius 110, diameter is 220. Okay, that's also clear. So this will go for what? 110 it will go. Then further. That detail is not required. We will put later. 2 over. 3. I will take, this is 3. For 3, the base is 120. See here. They gave here, there, I am writing here 120 base. Height of the triangle is total 300, subtract 110, that is 190. You have to calculate it, 190. Okay. 3 over. Fourth one is, this is fourth one. This is the fourth one. Okay, now, fourth one, sorry, I won't write now. 3 is the right angle triangle, 4 right angle triangle, you write. Fifth is quadrant, sorry, semicircle. Okay, this I will take fifth, 5. For 5, already over, see, Radius they told 75. So where I have to write somewhere 75 here. Okay, see, I'll put here now. This is 75 if required. 75. That is 75. So diameter is 150. I will write diameter here because here if I write, I can write there. I don't know. I think I can write space. Depending on the space I will do. If space is there, I will shift it here, 150. Okay. Diameter 150 over. Fourth one, you require this distance. See, suppose you take this as x, no, not x, a, this is not a, b, c, distance d. That distance is not known. What you do? See here. Now, this is 265. See, from here to here is 265. You already got it. Whereas from here to here is, or you can do one thing now, 265 over 80 plus 150 up to here now. Oh, no, not required. See, this is 200. If this is 200, you calculate, this is what you calculate what is this distance. See here. That distance is, see, this distance, see correct clear, A, B, C, D, I will put E point here. You calculate what is ED. Your ED equal to the base of the rectangle, which is already calculated as 265. 265 is the, see, 265 is this base. If it is 265, subtract 110. Subtract 110. 265 minus 110 will give you 155, correct? Yes, 155. So, E to D is 155. See, once E to D is 155, this is D, that missing distance D equal to 200 minus 155. 200 minus 155 will be 45. See, this is 45, missing distance. Of course, these are all high school level mathematics. Okay, now every dimension is cleared. That is okay. Now you get the overall dimension. See, complete boundary. See, this is the topmost edge. See, extended here. This is the bottommost edge. Full height you require. Full height equal to 300 plus 75. 375. I am rounding off. Full height. And you require the full here. See, this, see now. This is the right extreme edge. See here. Right extreme edge is here. Later I may require it actually. Okay. This total from, see, from this extreme end, this extreme end, this extreme left to extreme right will be 120. This is 120 plus 260, 120 plus 265 plus another 45 is 430. That's how I got 430 there. Now everything is clear. Now question is locating centroid for each part. Okay, start. Centroid for one by one. See, centroid for this rectangle first. Be careful, this 30 is required. This is 265. 265 by 2. 265 by 2 is, anything missing? No, nothing. 265 by 2 is 132.5. See, 132.5 here or from here. 80 plus 30 is 110. So how much I told? 132.5. So it is further this side. Whereas 80 plus half of 150. 80 plus 150 by 2 is 155. From here to here is 155. From here to here is what? 110. So how much I told answer? 265 divided by 2 is 132.5. So 132.5 is center. So it is after 110, but before this is 80 plus 75 is 155. Up to here is 155, 137.5. So after this point, how much more? 155 minus 130. 2.5 is further 22.5, maybe somewhere here. See, somewhat scale required now. Okay, slightly I will shift it because it does not look like to scale. One ನಿಮಿಷ. ಒಂದು ಎರಡು ಮೂರು nearly 4, 1 little less than, okay, somewhere here. But actually little out of scale because this is 110, that is, how much it is? 132.5 over 132.5 minus 110 is only 22.5. Okay, now I can't do anything. Okay, somewhere here. Let me see. Little out of scale. 80, 35. If this is 35, this 80 should have been made little more. I think now I cannot change the sketch. See, now it is not possible to change the sketch. 110, 80, 30. Okay, now I can't change 80 and 30. Okay, such things we are helpless. So I will do one thing. Somewhat reasonably I will mark here. Okay, somewhat. Okay, little this side. Okay. Okay, agreed. See, these two are equal, remember. Both are half of 265. Imagine, okay. This should have made that changes here. But that's all construction. See, you don't know. To write this sketch, I took nearly 1 hour. Okay, now, vertically, this is 300, 300 by 2, 300 by 2. See, this is 190. So, below 190 it is 150. 40, from here, 40 below. Little below. Okay, okay. Little below. Now, okay, I think. Okay, done. This is your G1. Don't give too much importance to that one. Actually, this 80 should have been made little more. If I made it little more, then this point would have come somewhere here. Reasonably, okay. Now leave it. Okay, G1 over. G2. See, somewhere here. This is important. Thousands of time told. G2. Remember, I'll tell now only. This is G1. Half of 165, 265, half of 265, half of 300, half of 300. Okay, the 150 I'll ship it here later. G2, see correctly. This I will not tell again and again. 2d by 3 pi, 2d from here, see, center is here. From this center either side you have to see. 2d by 3 pi, 2d by 3 pi is 2 into 220 by 3 pi. Make a note if you want. For fifth one, see here, G5. This way, it is midpoint. 150 means 75 here and 75 here. But this way, this is 2d by 3 pi, 2 into 150 by 3 pi. This is also clear. Then third one, see, divide this 120 into 3 parts. Divide this 190 also into 3 parts. So, from here, first part. This is centroid for 3, G3. Now, this is 1 by 3 of 120. This is, from here, see, 1, see, if it's a marking there, you mark here. See, 1 by 3 of 120, 2 by 3 of 120. Whereas 1 by 3 of 190, 2 by 3 of 190. This I will not explain once again. G4, divide this height 300 into 3 parts. 100 comes here, this 100. Huh? Oh, this is not 100, this is 110. Oh, okay. No problem. See, I have not used it, it's 110. Oh, by mistake, 300. See, 100 comes here. So, divide into 3 parts. So, somewhere here. Okay. This way 3 parts, this way also 3 parts. This is the centroid. G4. And remember, this is 45. This way is 1/3 of 45. From here, 2/3 of 45. Vertically, so not that way, little down. G4, okay. G4 because this is 1/3 of 300. 1/3 of 300 is 100. This is 110. Therefore, if you see this level, if you go this level, your G4 is slightly above, very slightly above 1/3. Okay, now little out of scale, what to do? I have to maintain it now, see? Well, because actually it may come up to here, but this 110, 190 are not exact to scale, that's the problem. Okay, 1/3, 2/3 of 300. Now important, 1/3 of 300 is 100. This is 110, so it is slightly above, 10 mm above. Okay, no problem. Okay, over. Everything is over now. Now, to this sketch I will remove. Anything missing now? I explain 110, 265, 45, 430, 300, 75 I told. Total 375, 120, 80, 30 told, 150. Little problem for scale here. See, 80. See now what happened is 80. 80 plus 80. 80 should have been little bigger. Now I will try to change, if possible I will try to change it now. Only if possible I will try to change. Okay, now I will go for centroid location. We will go for first O origin here, that is Abelco, and locate centroid. We will try to change just if possible. Start now. I slightly shifted it, but further I can't do it. And this diameter I have tried somewhere. See, this is 150. I write here. Hope it is not disturbing later. 150. Okay, diameter 150 inside. Actually, 30 is not required. Okay, we'll see later. Now start. Location of centroid G. Don't see this number. This I calculated. Okay. Location of centroid G. Don't see any extra number if I wrote, don't see it. Note, actual is 1 minus 2 plus 3 plus 4 plus 5. Now, what all I dictate, you have to write. First, Abelco. See, origin here. Bottom, extreme bottom, see, extreme bottom and extreme left origin, that is Abelco. If anybody will, actually those who already studied centroid from me, they know it. Don't write Abelco. Let us consider origin, O as origin with the XY as shown you write there, that's all. Abelco, Eterco, don't write. Okay, now X this way, see from this line, Y this way from bottom edge. Now write X bar from OY. This I will not tell. If anybody expects, write the formula, leave the class. X bar from OX equal to A1 X1 minus A2 X2. See, danger. I'll do one thing. I put red color for 2. It's danger one. Extra red color for 2. It is a danger one. A1 X1 minus A2 X2 plus A3 X3 plus A4 X4 plus A5 X5 divided by total area A1 minus A2 plus A3 plus A4 plus A5. Okay, start. A1 265 into 300. I wrote the answer. A2, this quadrant, pi by 16 of 220 square. A3, this triangle, half into 120 into 190. 190 is not properly visible here. Okay, 190. 190, okay. A4, half into 45 into 300. A5, pi by 8 of diameter square, diameter 150. Okay. Now, A1 minus A2 plus A3 plus A4 plus A5, you get total area A. Now X, G1, see, 120 plus half of 265, X1, X2, see here, from here, 120, see, this is 120 plus 2d by 3 pi, 2 into 220 by 3 pi, write it, X3, see, this is 120, so this is 2 by 3 of 120 over X4, 120 plus 265 plus this distance is 1 by 3 of 45. Or you can do one thing, you can write one more thing for X4, 430 minus 2/3 of 45. That also will do. Right in the bracket right here, in the bracket. X5, centroid here, 120 plus 80 plus half of 150. You get X5. With this data, get X bar, Y bar. I'll write somewhere here. See, where I'll write no answer. What X bar I got. I will write here now. See, this I remove. See, with Abelco, I write here. With Abelco, I got X bar 252.948 and Y bar 191.603, means from left to right and vertically bottom to top. This is to right side. Actually, I should not tell. This is to right side. This is to up. Make a note of the answer. Okay, this is Abelco. No, not that way. You have to substitute here. Substituting X bar from OY equal to show the calculation and get the answer. Not this way, not what I got. You should get it. Okay, now, after Abelco, now go to Aterco. Now, actually over. See, once you get X bar, Y bar, now you can locate centroid. But still, so how to locate centroid means I will tell you later. Okay, I will locate later. Now, only for this question, just to make concept pakka clear, full clear. The pakka is a Indian word, okay, fully clear. I will take origin here. See, I will take origin here. That is Aterco. I will take Aterco here. Oh, both are black color. Huh? Yes, both are black. I should bring the green color is here. See, I will take origin O here now. O here. And I will take X this way and Y this way. Now, remove this one, time being. Don't write this one now. Remove it. Independently, right? Not Abelco, write Aterco. Right? Aterco. Aterco. Extreme top and extreme right origin, Aterco. Now your X will be to left side and Y will be to down. So X from OY will be to left side, X from OX will be down. This will change. Okay, now start. Area will remain same. These all will change. You write once again, make a note. Not this way. Once again put the table. Don't be lazy and strike this way. Okay, start now. Systematically start. G1 here. From here, X. 45 plus half of 265. 45 plus 265 by 2. 45 plus 265 by 2 equal to, I will check the answer. 45 plus 265 divided by 2 is 177.5. x2 centroid here. 45 plus 265 subtract this distance, that is 2 into 220 divided by 3 pi. If anybody will ask, sir, why means no answer from me, I will tell usual, leave my class and study somewhere else. 263.315 x3 from here. See, centroid is here. Actually, you can do easy one. See, 45 plus 265 plus 265 plus, from up to here you can't see, then plus this distance is plus 1 by 3 of 120. 45 plus 65, 45 plus 265 plus 120 by 3 is 350. Or you can do one thing. From 430, subtract 2/3 of 120. 2 by 3 of 120 is same, 350. x4, see here, this centroid. From here, see, this is, I told, this is 1 by 3, this is 2 by 3, thousands of time told, 2 by 3 of 45 directly. 2 by 3 of 45. 2 by 3 of 45 is 30. And x5 from here, see, 45 plus 35, 45 plus 35 plus, from here to center, see, this is 2d by 3 pi, but this is center, plus 150 by 2. 45 plus 35 plus 150 by 2 is 155. With this value, I will write here now, with Aterco, see, with Aterco, x bar will come, x bar is to left side now, x bar will come 79500 into, see, this time I am really doing it. I do not want any mistake. 79500 into 177.5 minus 9503.318 into 263.315 plus 11400 into 350 plus 6750 into 30 plus 8835.729 into 155 divided by total area. I already stored in the memory 177 point, I am getting 177 point, you should show the calculation, 177.052. Let us see correct or not later. 052, I got x bar. Now y distance from here. Start. y1, half of 300. See, this is 300, half of 300. 300 by 2 is 150. y2, this distance is directly 2d by 3 pi. 2 into 220 divided by 3 pi. 2 into 220 divided by 3 pi. 2 into 220 divided by 3 divided by 3 pi. 46.685. y3, where is 3 here? See, from here to here, 110 plus from here to here, this is 1 by 3, this is 2 by 3 plus 2 by 3 of 190. 110 plus 2 by 3 of 190 is 236.667. Nice, 667. One missing. Okay. I'll write somewhere here. X5, okay, no problem. Space problem is there. I should write here with this is with what? Eterco. Okay. Y4. This is directly 1 by 3 of 300. Last one, Y5. 300 plus this distance is 2d by 3 pi. 300 plus 2 into 150 by 3 pi equal to 300 plus 2 into 150 divided by 3 divided by shift pi. See, I am doing slow calculation. 331.831. 831. With this value, with Eterco, I will get, now you show the calculation. Therefore, y bar equal to write formula and everything you require, show the calculation, get y bar. $79500 into 150 minus 9503.318 into 46.685 plus 11400. See, very slow. Actually, I do high speed calculation. My calculator got a problem. So sometimes zero when I put 11400, one of the zero will not come due to some reason. Then wrong answer will come. So I am careful now. 00 into 236.667 it is. 36.667 I think it is. It is 667. Okay. It is 667. Correct, huh? 1 by 3, 667, yes, correct. It can't be 667 only, correct. 667. 667 plus 6750 into 100 plus 8835.729 into 331.831 equal to divided by total area 183.397 is my y bar. Okay, I got the answer. Now I will remove everything and I have to go for moment of inertia. X bar, y bar, location, I will tell you the next round. Next round means note, I am solving the question or marking dimension as if I am a beginner. I am not the beginner. That is, I am so that even those people who have difficulty, they will understand. Don't think that I am doing so slowly, this will come, I can, by looking only I can make out. But still, as if I am a beginner, I am solving. See, start now. Earlier, see, first now. Now, correctly, locate your G. This color is gone, I will change the pen. Okay. Now, locate centroid G. Locate G using X bar and Y bar as per Abelco. This value, Abelco. Okay, start. X bar is to see. Now, once again, remember, remove this one. You put one more sketch there. Okay, remove that one. Start. Your origin is, see, once again, mark the origin because you continue this origin only. This is origin O. This is X, this is Y. See, X bar, you got 252.948. So start. 120. So further you have to go. Okay, then 120 plus 80, 200. So further you have to go. That 30 is not required. I removed it. See, this line and this here, see, this edge and this edge difference is 30. It is not required. If requirement is there, I will put right once again. Okay, now 120 plus 80 is 200. So further you have to go. 252. Now, from here to centroid of the semicircle, 120 plus 80 plus 150 by 2, 275. Oh, before the centroid, by 275. Okay, now there is a little scale problem is there. The G1 should have been shifted slightly this side to make further. If I shift, looks very ugly actually. See, okay, slightly I will shift G1 so that distance wise, okay, G1 centroid of rectangle. It looks very, very odd for me. It comes because see, these are equal. No, leave it. G1. Okay, now that G1 I will write this side for some reason. G1. There's a reason for it. G1. Okay, now so it is before this G5. Come this side. 120. See, 120 plus half of 265. 120 plus 265 by 2 is 252.5. Oh, 252.5 is from here up to G1. X bar 252.948. Half millimeter. Mic very small. So your centroid will be slightly after G1. See, very, very slightly after G1. But it should be, see, this way. See, now I have to shift. Okay, no problem. G1 I write here now. Remember, this is G1 very slightly, but I'll do one thing now. To make clear, I'll shift a little more. Otherwise, people will think both are same dimensions. Okay. Okay, see. It will come here, but it will not go up to here. It will be further left side. There's a scale problem here. Okay, no problem. That you don't make issue. Why? And from here, your X bar is 252. I change the color of the ink. It is little not dark. I'll write it. I got a fresh pen with the dark color. 252.948. 948. I will round off. This is this distance. I will round off to understand. That is the X bar value. You write X bar from Abelco. If that is 252.948, from this extreme end, see here, from this extreme end here, up to here, this distance will be total, I am not seeing there, total 430 minus 252.948 is 167.052. 167.052. Again I am rounding off. And remove this one. Okay. 167.052 from that side. Then Y bar. Total 430, correct? From 430 subtract 252.948 is 177. Oh, 177. See, I don't know from where. I got a shock here. See, from total 430, I subtracted wrong number. From total 430, subtract 252.948. 177.052. Got a shock of my life because see, answer here. 177.0. I did so carefully. Okay, 052. You will check later. y bar from here, see, from this extreme end here, bottom extreme end, 191.603. From here to here is 75. So further above. 75 up to here plus 1/3 of 190. 75 plus 1 by 3 of 190 is 138. How much you got? 191. Okay, go further. From here to this edge here is, how much is? 75 plus 190. 75 plus 190 is 265. 265. But how much you got? 191. So from here to this centroid is 75 plus 1 by 3 of, how much it is? 190 is 138. You got 191. So little above. See? Little above. Not too much above, 138. Up to here is how much I told? 265. So little out of scale, nothing can be done. You do one thing, take a drawing sheet and do it. This is your x-axis axis. Okay, I'll do one thing now. These dimensions are there. It is disturbing actually. So what I will do is, see, x-axis, I'll remove here. I'll bring here. I'll further bring here, x-axis. This is your x-axis. So from the bottommost edge up to here is your y bar. 191.603 is the value. Then from the top extreme end, I have got limited space for moment of inertia. I should manage. This distance is total 375. From 375 minus 191.603 is 183.397. 183 point, little out of scale, 183.397. Actually, you do one thing. You mark everything in the drawing sheet to scale. Then beautifully it will come. Okay. Over. Now, centroid is here. This is the x, x, y, y over. Now do one thing. Those people who solve with Aterco, see, Aterco, their x bar is from here. Here. They get 177.052. Oh, see there. Exactly correct. Then, for them, from 430 subtract, you get this distance. And those who are going for Aterco, their y bar is from top. How much they will get? 183.397. Oh, yes, see here. 183.397. Then from total 375, subtract 183.397, you will get this distance. So perfectly matching. See, that is why, see, you get lot of happiness when things are so beautifully matching. People should get happy. At least your effort is rewarded. Okay, now everything over now. I will go for moment of inertia calculation. Before that, I will first finish the formality. I will finish formality, then I will not explain. Okay, this everything is over. Okay, now what all I dictate, you should write, otherwise you are losing. See, calculation of moment of inertia. I about xx, you should write it, and I about yy. By parallel axis theorem, write I about any axis equal to this, see, Ig plus area into red color y, danger number, into h square. What is Ig? Moment of inertia about its own centroidal axis parallel to required axis. When you want, and A, area, h, perpendicular distance from centroid of the component considered or part considered to the required axis. Now, when you do about x-axis axis, all distances are vertical. Okay, start. See, I tell you. For a triangle, I about its own axis, or a rectangle, I about its own centroidal axis. Okay, no, this I am explaining. I am writing in the board. Okay, no. Yes, I am writing in the board. Therefore, wait. Okay, this my statement you write. Then we will start. Now I will do one thing now. To save the time, I will write first and explain. I can write in front of you anyway because anyway I am not calculating it. But still I have to explain there, come here. When I come from there to here, some number may interchange. So to safer side, I will take my own time and neatly write here, seeing the space restriction here. See, I should be careful about space also. I will write and then explain. That's why I called this a very important question. I am explaining once again moment of inertia today. Start Ixx. See, the last term H, you should write horizontally, not one below other one. Here, space problem is there. See, you should write 252.948 minus 120 minus 265/2, close the bracket square. Don't write this way. Because if I write that way, sketch is spoiled. Okay, start. This today, I will explain briefly once again. Start. First, everywhere, first IG plus A into H square. Come to IG. Come to centroid. Axis passing to centroid parallel to X axis here. Or for all the 5 figures now, 5 parts now, when you want Ixx, you consider horizontal centroidal axis. See here, this axis, then see this axis, then this axis, I about this axis. That is your IG. See, this axis and this axis. Make a note. Okay, take a pencil and write. Start. For this axis, parallel side is 265, height is 300, 265 into 300 cube by 12 rectangle plus area into from centroid G1 to Xx. This distance square is 183.397 minus half of 300. Where is it? Why I put 252? Oh, I was writing IYY. Okay. My mistake I wrote. I changed it. I was writing IYY. Okay. That is how much? 150. See, I can make out 183.397. Actually, when I was about to write H, I was thinking I was doing IYY. 183.397 minus 300 by 2. See, such mistake if it happens, I can make out immediately. 300 by 2 whole square. See, this distance minus this distance is this distance. Okay. Come to figure number 2, part number 2. Its own centroidal axis. It is a quadrant of a circle. For a quadrant, the word symmetry does not exist. So then decimal number is there. What is the decimal? Pi is not there. Again, I am telling 1000 times. Decimal number for semicircle is 0.00686. For quadrant, it's half 0.00343 into diameter power 4 plus area into from centroid G2 to Xx, this distance square. That is 183.397 minus this distance is 2 into diameter by 3 pi, everything whole square. Okay. Come to figure 3, part 3 here. I about its own axis. It is a right angle triangle. So for this axis, the parallel is 120. So 120 into or I told you, when you want I about X horizontal axis, cube is for vertical side. When you want I about YY axis, cube is for horizontal side. Or if you want I about XX, parallel is horizontal, perpendicular is vertical. This I told you so many times. So 120 base parallel side into 190 cube divided by 36 triangle plus area into from centroid G3 to Xx. See, this distance square. this distance square is 191.603 minus 75. See the 75 there? You got this distance. Again minus 1 by 3 of 190. Okay. 1 by 3 of 190. Okay. Now, fourth one. I about its own centroidal axis. 45 parallel. 45 into 300 cube by 36. Plus area into, area I am not explaining, from centroid G4 to XX perpendicular square is this full distance 183.397 minus this distance is 1 by 3 of 300 whole square. Lastly, semicircle. I about its own centroidal axis. Oh, this is not axis of symmetry. Why? Symmetry is here. So, when symmetry is not there, for semicircle, I about centroidal axis is pi is not there. Always diameter power 4 decimal number. Semicircle decimal number is 0.00686. 0.00686 into 220 power 4 plus area into from centroid G5 to XX. See, this distance square. That is, see, from G5 to XX. Be very careful. This distance square. For that distance square, start 191.603 is from here up to extreme end. Then from 161.603 you subtract 75. You will get this distance. See, you will get from where? You will get see 191.603 minus 75 will give you this distance. Then plus extra distance here is 2d by 3 pi. 2 into 150 by 3 pi whole square IXX. Now you enjoy. Now I won't waste time. If I tell, it's waste of my energy. Calculate each and every one. Right lastly, therefore, IXX for the given area, that is the real area, is IXX power 1 minus IXX power 2. Danger, see, minus IXX power 2, see, danger here, plus IXX power 3 plus IXX power 4 plus IXX power 5. When I do YY, I won't tell this one. I will tell enjoy. Over. Get the answer. And if you know any friends who are really serious like you ask him what answer he got, compare. Okay. But anyway, answer is not important. You should take independent paper without referring my class. You should write expressions and practice. Okay, now IXX over. Lastly, I will go for IYY now. Now, I about YY. Once again, last time I will tell moment of inertia about the vertical centroidal axis. Therefore, all distance square will be horizontal square. When you put IG plus A square, vertical axis means this distance square. Okay. Then, everywhere IG plus A square. So, therefore, I will first explain IG first here to save the time. The most powerful term, that is H, I will explain last. The pen cap fell down. Okay, see, start. Now I remove, see, do one thing, you take pencil and remove the previous one. See, I about YY. So for figure 1, its own centroidal axis is here. For figure 2, its own centroidal axis is here. Figure 3, its own axis is here. Figure 4, its own centroidal axis is here. Figure 5, see, this is its own centroidal axis. Okay, first for everything you write systematically IG for 1. Vertical, this is the axis. So parallel side 300 into 265 cube by 12 plus area into H square. I will explain H last. Last I will tell. Figure 2. I about its own centroidal axis. Quadrant of a circle, whichever axis you take, it is same 0.00343 diameter power 4 plus area into h square. Figure 3. I about this axis. Now the parallel is 190. So 190 into 120 cube by 36 plus area into distance square. Okay, h square. Figure 4. I about this axis. The parallel side is 300. 300 into 45 cube by 36 plus area into distance square. Lastly here, I about its own centroidal axis. This is the symmetry axis. For semicircle, this is symmetry axis. If it is symmetry axis for semicircle, its I is half that of circle. Circle is pi d power 4 by 64. Its half is pi d power 4 by 128. So everywhere Ig explained, area explained. Now come to the most powerful term h square. See, figure 1. From centroid, see I about its own axis plus area into this distance square. That distance square is, I wrote last time, 252.948. 252.948. See, this distance minus 120, again minus this half the distance from here up to centroid is 265 by 2. Here little scale problem is there, adjust it, whole square. Figure 2 or component 2. I about its own axis plus area into, see, this distance square. That distance is 252.948. Once you understand the principle, there is nothing. 254.948 minus 120. So what you got now? So from, see, 254 point something minus 120 minus this distance is 2d by 3 pi minus 2 into diameter is 220 divided by 3 pi, right horizontally whole square, right horizontally 3. From I about its own axis already over plus area into from centroid here, see, this distance square, that is 252.948 from this distance subtract this distance. This distance is 2 by 3 of 120. That's all. Minus 2 by 3 of 120 whole square. Fourth one. I about its own centroidal axis, already over. Area into from G4, see, this distance square, that is 177.052, that is from here up to extreme end here, subtract this distance, see, this distance, this is 45 means this is 1 by 3, this is 2 by 3, minus 2 by 3 of 45 whole square. Lastly, I about its own axis plus area into this distance square is 177.052. 052, see, this full distance. Then see here, 177.052 is up to where? Up to here. See, it is up to here. Be careful. So, minus this distance is 45 minus 45, again minus 35, you reach it up to here, again minus this distance is half of 150, little big bracket, minus 150 by 2 whole square, horizontally write it. Now get all the values. You enjoy. If anybody will ask now, sir, what to do next means, suppose someone will ask, I'm in a offline class, they will ask, sir, what to do next? I will silently put this way and tell, go without looking at him. That's what I am doing now. So now, over the question, go through systematically, study and understand all the concept. Now, earlier also we have done some 2-3 master question. This also is somewhat master question. Now, the coming up questions are easier. This much complications are not there. So, don't expect me every class to explain centroid. Once again, I will try to select the question which is already considered for centroid, so that I can save time of locating centroid. I can tell previous lecture number. You can go there, write it and make fair copy. Okay. We'll meet next class. Thank you.